In this video, I'll be working through the question you see on the screen from the Pure Maths paper 3, specifically paper 3.1 from Cambridge A-level exams from 2024. If you're looking for any other question from this paper, you should find a playlist in the description below. And if you're looking for any other paper, look around on my channel. I'll be doing all this on a whiteboard, hopefully just like you're used to your teacher doing. But of course, this isn't the classroom, we're on YouTube, so go ahead and take advantage of that. Pause, rewind, watch at 2x speed, whatever you find useful. If you find any of my videos useful, I would appreciate like, subscribe, or sharing it with someone else doing the A-level exams. In question 9, we're going to be talking about two straight lines in a three-dimensional space, and these lines are going to be defined using vectors. And we're going to use vectors to solve all the questions. Part A is quite short. Part A is just 1 mark. So we should be able to do part A very quickly. I'm going to spend just a little time reminding you what a line is, because it's going to help in part A, B and C. So just remind you what vectors are. We have a 0, 0 point. To define a line in a vector, we first of all get a vector going somewhere to the line. So imagine this is the line here. One vector goes to the line, that's this one here. And then the second vector it goes somewhere on the line, like that. And when we combine these two with any number you want, you can get anywhere on the line. For example, you go to the line and you move one of these vectors, you get here. You go to the line, you move half of this vector, you get here. You move 3 of the vector, you get here. Minus 2 of the vector, down here. So by changing this number, you get every single place on this line. Okay, that's just a quick reminder. Back to the question. The question asks you to show that A is equal to 4, and they tell us that these two lines are perpendicular. So there's another line. It's perpendicular to this one. It also has a vector going to it and a vector on it. It's these two vectors that are important to us. It's these two that are perpendicular. So yeah, let me draw these two again, but just beside each other. These two vectors that are perpendicular, and they're these ones here. This second vector in these equations of a line. So this one is 2 minus 1a, and this vector is 3 minus 2 minus 2. Oh, I should say I write vectors like this just to save me some time. Instead of the I, j and k, this is just I minus 2j plus 3k. That's I'm going to stay using that because it just saves me some time. Okay, so what we know is these two vectors are perpendicular. This vector and this vector. And that's what they expect you to do straight away. Knowing a vector is perpendicular, we can then talk about its dot product. Let's just write this one more time. The dot product of these two vectors. And the dot product is in your formula book. The dot product is the length of the two vectors multiplied together and then multiplied by cosine of the angle between them. But the angle, the cosine of 90 is 0. So the dot product of this is 0. That's what they want you to write straight away. This is what they'd expect to have seen. This equals 0 and solve this for A. So the dot product is easy. It's the I parts multiplied. 2 times 3 is 6. The j parts multiplied, minus 1 by minus 2 is plus 2. And the k parts is minus 2a. And just solve for this. 6 plus 2 is 8, move that over. Minus 8 equals minus 2a. Divide both by minus 2, we get a is equal to 4. That's the answer to part A. Right, let me clear off the board and we'll do part B. Okay, for part B, I'm just going to replace the A with a 4, and yeah, how do we get the point of intersection? Sorry, that's the question, part B. Point of intersection. That's just when this line equals this line. We'll just put them equal to each other. Let me write this one more way here. I can add the I parts. This is 1i plus 2 lambda i's. So really, I can write this as 1 plus 2 lambda. I can write this as minus 2 minus lambda, and the k part is 3 plus 4 lambda. 3 plus 4 lambda. That's line 1, and that's equal to line 2, which is minus 1 plus 3 mu, minus 1 minus 2 mu, and minus 1 minus 2 mu. Put these equal to each other. And all we have to do is solve this. It looks like one equation with two unknowns, lambda and mu, but it's actually three equations. All the i's equal each other, all the j's equal each other, and all the k's equal each other. So go ahead and solve this. We'll just take the first line here and the second one. 1 plus 2 lambda equals minus 1 plus 3 mu. And we'll take the second one, minus 2 minus lambda equals minus 1 minus 2 mu. Two equations, two unknowns. We can go ahead and solve this. Let's see, 2 times the bottom row added in. So that'll be 1 minus 4, which is minus 3. That'll disappear. 2 times the bottom row that's minus 3. And that'll be minus 4 plus 3, that's minus mu. Let's see, they cancel. We get mu is equal to 0. Will be the answer to that. Fill that back in to anywhere you want and we get lambda. So let's see, that's 1. Let me write that again. This top row here, we'd have 2 lambda. Sorry, 2 lambda is equal to minus 2 plus 0 plus 0. So lambda is equal to minus 1. That's the answer for lambda and mu. You could do something here. You could go ahead and solve the second and third one. If you get the same answer, I guess you'd have to do the first and the third one as well. And you keep getting the same answer, that proves they intersect. But that's a silly way to do it. We wouldn't do that. What we'd usually do is we just find one answer, the mu and lambda here, one of these answers, one set of these answers. Sorry, let me go back a second. You will always be able to find an answer for lambda and mu, even if these lines don't intersect. Remember, we're in 3 dimensions here. Lines don't have to intersect. They can miss each other. And if they miss each other, you'd get an answer for this and different answer depending on which tree you do. So how we deal with that is we get one of our answers and fill it into the top. So for this time it's minus 1. This line becomes 1 minus 2. That's minus 1. And minus 2 plus 1. That's a minus 1. We get 3 minus 1 times 4 is minus 4. 3 minus 4 is minus 1. That's what I get if I put lambda as minus 1 in here. If I put mu in here, that's much easier. I go ahead and get 0. So I just get minus 1, minus 1, minus 1. They agree. They do have the same point. They both have the same point in them. They must intersect. That's the intersection point. That's just one answer there, by the way. This is the intersection point of these two lines. Hopefully I was clear there. What I mean is if you ever find they don't intersect, trying to solve this, you will get 3 different answers. They'll just never agree. You think you'll get an answer from mu and lambda, you'll put them in and they won't equal. They'll equal on one of the lines. Sorry, 2 of the lines I guess, but they won't equal on the third line. Hopefully that's clear. In part C, they give us a position vector for A, and they tell us that's equal to minus 5, 1, and minus 9. And they want us to show that A lies on L. Again, this is a very simple, straightforward question. It's we just go ahead and see if this equals this and solve for lambda and make sure that it does. So here's what I mean. If this lies on this, then this is a solution of this with a certain lambda. Okay, hopefully this will make it clear. This equals this is what I'm going to try and do. And remember, just like we did before, this will be 1 plus 2 lambda. 1 plus 2 lambda, oh sorry, one big bracket, minus 2 minus lambda, 3 plus 4 lambda. If A is on this, I will get the same lambda for no matter what line I use. Actually, very similar to the previous question. Just pick any line you want and solve it. So the top line is minus 5 is equal to 1 plus 2 lambda. That's minus 6 is equal to 2 lambda. Lambda is equal to minus 3. That doesn't prove it's on it. That doesn't prove A is on it. If you go ahead and solve all three of these and you get lambda is -3 for all of them, that does. That's one way to do it. A much easier way though is once you get one answer, put it back in up here. So we get 1 minus 3 times 2. So that's 1 minus 6. Let's just put that down here. 1 minus 6 is -5. Minus 2 plus 3 is -2 plus 3 is 1. And then 3 minus 12 is -9. It agrees. Yeah. You got the correct answer. That shows that A is on that line. And that's all you have to do. But like I said, you could go ahead and solve any one of these. You would have got -3 for all of them. And that in and of itself proves that it's on the line. Okay, in part D, they tell us that there's a point B that's the reflection through the line L2 of the position vector A, of the point A. There's only 2 marks for this question, but I think it's a bit difficult, so I don't know if I'm doing it some silly way. So have a look what I do. Let me know if you think, oh, that was a bit stupid, I could have done it shorter. Let me draw what's happening first of all. We have a line 2. So let's draw line 2. That's L2 here. We have a position vector A. So we'll start off at the 0, 0 point, and we have point A here. Here's point A. And we got the position vector to that. That was, I've rubbed it out here, but A was equal to, let me check my notes, -5, -5, 1, -9. So that's A here. Put A down here. What the question D tells us is there's a point B that's reflection through this line. So we reflect through this line and we get this point B. They just want to find the vector from the 0 point to B. That's all this question is. Yeah, how do we do this though? I thought it was a little difficult. I'll remind you what L2 is. L2 is, there's a vector to it that's -1, -1, -1. And there's a vector on it that's 3, -2, -2. Don't worry about my drawing here, like this one's clearly longer than this one. It's 3 dimensions, it doesn't have to make sense. In fact, later on in the question, we're going to find out this drawing is completely wrong because it's actually a simpler drawing, but it's not as good to explain it. So I know this is wrong right now, don't worry about it later on. It's going to get the answer. So anyway, this defines this line here. What I want to do is get a vector on this line. That's really what I want to do. I have this vector. This vector is -5, 1, -9. I really want to get this vector, and then this plus this equals the answer. The answer goes 0 straight to B. Okay, but I'm going to go ahead and use this to help me get there. So how do we do that? Well, instead of getting this vector first, this A to B vector, I'm going to give up on that and I'm going to try and get this vector. Because this vector is half of this. If I get this, I can very easily just multiply by 2 and get that one. Okay, so that's my plan here. And the reason I'm going to do this is because I know everything about this line. This tells me everything about this line, and this point is on this line. So I can say this point here, we'll call it C. This point C. Point C is equal to this. It's equal to -1 plus 3 mu. -1 minus 2 mu, -1 minus 2 mu. Because it's on the line, so it has to equal this. I just don't know what mu is. Okay? But then I also know, so that's this vector here, going all the way to C. This one here. But I also know AC. The vector AC has to equal this vector minus this vector. So AC has to equal this vector minus this one. So that's -1 plus 5. That's 4 plus 3 mu. -1 minus 1. That's -2. -2 mu. -1 minus -9. That's plus 9. That's 8 minus 2 mu. This is the vector AC. Now what's interesting about AC is I know it's perpendicular to this guy. So I know, let's see, AC dot product, I guess just this guy here, 3 minus 2 minus 2 equals 0. So I can just do that. The dot product of these two, 3 multiplied by this is, I think I'll have room down here to do it, is 12 plus 9 mu. Minus 2 times this is plus 4 mu. Minus 2 times this is minus 16 plus 4 mu. And that all equals 0. I can clean this up. The numbers are 12 plus 4 minus 16. That's 0. And the mu's are 13, 17. We get 17 mu equals 0. Mu is equal 0, which is actually the same answer as we got previously. If I put mu in as 0, I can find what C is, or more importantly AC. Let's find AC, because I want 2 times that. If I put mu in as 0, AC becomes, I'll fit some of this down here. AC becomes 4 minus 2, 8. AB is just 2 times this. AB equals 2 times AC, which equals, I'll squeeze it in here, 8 minus 4, 16. That's 8 minus 4, 16. And I guess I'll squeeze in the final answer here. I'm looking for B. B is simply equal to A, that's this one, plus AB. Plus AB. And we have A's right here, and we have AB, that's right here. Add these together, minus 5 plus 8 is 3. 1 minus 4 is minus 3. Minus 9 plus 16 is 7. And that's my answer for B. Let me just double check that is indeed right. That's the correct answer there for B. I felt that's a fairly long way to get 2 marks. So I don't know, I think I might be doing something silly here. So let me know if you can see an easier way to do that. I guess it's a common enough question, so some students probably were able to skip some of the parts and know that they were, I don't know, maybe skip to somewhere down here. Anyway, let me know if you found a shortcut to that or an easier way than I did it. Or maybe I just made a mistake somewhere. Let me know. Thanks for watching. Have a good day.